Sierra Turbines is a startup. We were founded in 2017, not far from the VELO headquarters. We saw an opportunity to work on small microturbines for a whole host of applications. We're focused on unmanned systems, but we're also interested in ground-based applications where power density is a critical factor. This small category of microturbine, what we call the service interval, the time between overhauls, has been hamstrung by the materials. And so HASTELLOY X is a material that our engineers have worked with. We understand how that material works for improving the service life of these gas turbines. And so the current turbines today, these small turbines, have a service interval that's measured in tens of hours. And so we intend to bring that up to the commercial level of at least 3,000 hours between overhaul. And so that's the point number one, the time between overhaul. A 40x improvement over what's possible today. And so point number two is power density. And so we see this as a solution for competing against both fuel cells and batteries. And so we are a 10x in terms of power density compared to batteries or even fuel cells. And so what that will allow you to do is take your drone that is limited to 30 minutes and now you can fly for 3 hours. So that's the 10x in terms of power density of 200 watt hours for batteries compared to 2,000 watt hours for a turbo generator. And for weight savings, this is where we've really embraced additive manufacturing. And so we've been able to combine over 61 sub-assemblies into one. In particular, the work that we did with both VELO and topology, our fuel injection ring, has saved on 17 different sub-assemblies. And so, what we've seen is that we've been able to cut the weight by 50% by consolidation of parts and really embracing, the intricate features of design for additive manufacturing. The field of microturbines, the critical need is manufacturability. And so to address some of the shortcomings of density, we aim to use additive manufacturing in a capacity that it was really intended for. Additive manufacturing has actually been used in the aerospace industry for almost over a decade now, and as I mentioned, our team has familiarity with that aspect of additive manufacturing for low volume, high critical applications. And so we see that ability has never been tried at this level before. And so that's what we want to embrace, with our design. So we believe we have a design that, takes into account all of the benefits of additive manufacturing.
At VELO3D, we enable you to produce the most challenging geometries with uncompromised quality. There's a natural tension that resides between design and manufacturing. The designer wants the thinnest walls, the smoothest surfaces as they chase down the performance of the engine and lower the weight. On the other hand, manufacturing is worried about the manufacturability of the part, the producibility and the cost out. With VELO3D's support-free processes, this means fewer design constraints and really allows you to produce the geometry that you need to meet your customer's spec. In the case of Sierra Turbines, this part would have been completely solid full of supports. However, with VELO3D's suite of support-free processes, we're able to produce this part with no supports on the inside, which means a very easy to manufacture part as you print and cut it off the build plate without the supports being removed on the inside. Really, at the end of the day, this enabled Sierra Turbines to have a manufacturable solution while at the same time meeting the customer's spec.
So yes, the next steps are really to do hot testing of the static core. We really want to see how the HASTEX handles hot corrosion and also the creep characteristics of the HASTEX material. So that's a very critical piece for the immediate next steps. After that, we're going to be printing the rotating parts, and we're really looking forward to that one because these are highly stressed parts for which there's been some skepticism as to the properties of 3D printed turbines, and so we're really looking forward to that towards getting the engine up and running.